calculus students. Welcome to section 7.1, nonlinear systems of equations. So you were used to solving linear systems of equations, and they're very useful for a lot of problem solving in our man-made world because linear systems have changes that are constant and really good starting points. But there are systems of equations that are nonlinear, meaning that one of the equations, at least one of them, is not aligned, such as a circle or parabola or an ellipse, right? Some things that we've already talked about. Because there are patterns in our world, right, that don't take on a linear pattern, they take on a parabolic or an elliptical or circular. So let's jump to number 3. These systems represent patterns of occurrence, and their solutions can help us make decisions, right? So let's go to number 1. At least one equation is not aligned. And I think this is kind of cool. Here's some examples of the number of solutions you could have. Notice that in these 5 graphs, I have a parabola and a circle, right? A system of equations, right? And in our first graph here, notice the parabola and the circle do not have any points in common. And so there are no solutions to this system. Notice on our second graph, the parabola touches the circle at one point so that there is one solution. Lowering that parabola a little bit makes 2 solutions. Lowering the parabola even further so its vertex sits on the circle gives us 3 solutions. And again, lowering that parabola even further can give us 4 solutions where it intersects the circle. So pretty cool. So we solve these by substitution, sometimes using a squared term. So a lot of times, of course, we substitute an x or a y like we're used to with linear systems. But it could be that we are going to substitute an x squared or y squared term because we will have those going on in here. So let's try some examples from your book. Here's an example A. I picked number 10 from your book. Now there's 4 A, B, C, and D possibilities for 10, but I felt that we could just get a good feel for it by doing 2 of them. So hey, this looks like pre-calculus, doesn't it? Instead of a linear system, right? The second equation is aligned, but we have fractions, right? And the first equation, what, has a log in it? So, but what they're asking for in number 10, and problems like that I assign, is they give a list of solutions, and they're just possible solutions, and they're asking which points are solutions and which are not. So let's try the point 1, 3, meaning x is 1 and y is 3. And let's put it into the first equation that we see here. So we have a negative log of 1 plus 3 equals 3. All right, so let's first see if this is true. And if it is, then we'll try the point in the second equation and see if that's true also, to see if the system is true. Notice log, this is log base 10 of 1, right? All the way back to chapter 3 is 0, right? And 0 plus 3 is 3. Okay, so far that this point is working. Let's put it into the next equation. 1/9 times 1 plus 3 equals 28/9. Okay, well, let's see if this is true. I have 1/9 here. Now this 3 over 1, I'm going to write that as 27/9 because it's still 3, right? Oh, 20, I wrote a 3, sorry. 27/9 because it's still 3, right? But now we can actually add the fractions. 1/9 plus 27/9 is 28/9. And so C is a solution to this system. Let's try the point 2, 4. Okay, negative log of 2 plus 3 equals 4. Now, first of all, I can see that this isn't true. The reason why is log of 2. That means when the base is 10, what is the exponent that gets you 2? Well, not an integer answer, right? Certainly this would have to work out to be a 1 in some way, and that's not going to happen. So log of 2, if you put it in your calculator, you'll see is a decimal, and now it's a negative decimal, and there's no way when I add it to 3, I'm going to get a 4. But just in case you were unsure of that too, let's say that you started with the second equation here, and you put in a 2 for x and a 4 for y, and got 28 nines. And you would see here too, just in case you're unsure, this is a 2 nines. 4 I'm going to write as 36 nines. This is obviously not 28 nines. And so 2/4 is not a solution. Let's look at problem number 16 together. They're asking you to solve a system, and on number 16, they actually give you a graph also that shows the solution. So you can look at number 16 in your book, but I'm just going to solve for the solutions here. And you will take a look in your book and see that those actually are the solutions. So a couple ways to go here. I have a line in a cubic equation. So I think I'm going to try substitution. I believe what I'm going to do is it would be really nice in this more difficult equation if I only had x's. So in my first equation, I'm going to subtract an x from both sides. And my first equation can be rewritten as y equals negative x. Okay, so this means this y right here, I can replace with a negative x. Now be careful here with your negatives. There's a minus sign here, and this y is a negative x equals 0. Here we go. So now we have x cubed. This is minus 5x plus x is a minus 4x equals 0. Okay. Greatest common factor of an x. I can factor an x from both terms, and I have x squared minus 4 equals 0. Okay, I am going to set each of these terms equal to 0. Oh, I'm a little off the screen there. Hold on. There we go. I'm going to set each of these terms equal to 0. So I have x equals 0, and x squared minus 4 equals 0. Right. I'm going to add a 4, take the square root, and I am not going to forget my plus or minus. Now, notice in your book, when you look at the graph, that you actually do see that the solution, that there's 3 solutions, 1, 2, and 3. Plus or minus 2. Now, we have the x's of the solution right here, but the solutions are actually points. So I'm going to need the y's also. So I'm just going to come on up above here, and I have one solution is where my x is 0. One solution is where my x is 2. One solution is where my x is negative 2. And I'm also going to get the y's that go with that. And I made a nice little equation that does that for me here. So when I put in a 0 for here, I get a 0 out for y. When I put in a 2 for x, I get a negative 2 for y. When I put in a negative 2 for x, I get a 2 for y. And when you look at the graph in the book, on number 16, you do see that those are the 3 solutions where the line intersects the cubic equation. Okay, let's do 2 more examples. Here we go. Let's take a look at problem number 32. Notice x minus 2y is a line. 3x minus y squared equals 0 is a parabola, and it's also horizontal because the y is being squared. And so let's go ahead and solve this nonlinear system because one of the equations is not linear. I think there's a couple ways to go. I think a good way to go is in the top equation. It would be easy for me to get the x alone by adding a 2y to each side. So x is equal to 2y, and I will, for this x right here, replace it with 2y. So we have 3 times 2y minus y squared equals 0. 6y minus y squared equals 0. I have a greatest common factor of y, and I have 6 minus y equals 0. Here we go. Let's set each equal to 0. Y equals 0, and 6 minus y equals 0. Here we go. Notice that our y would have to be a 6 for this to be true. So we have two solutions to this system where y equals 0 and y equals 6. But again, the solutions are actually xy points, and I need the x that goes with these y. So here we go. I need the x that goes with a y of 0, and I need the x that goes with a y of 6. And when I look above, I made myself a little equation that does that for me. When I put in a 0 for y, I get a 0 for x. When I put in a 6 for y, I get a 12. And here are the two solutions to this system on number 32. Let's do one more problem. Okay, let's go to our last problem, number 68. Let's say you have a fast food restaurant. I've actually thought about that. We've talked about the Math Cafe, but there is another fast food restaurant I wanna own. We'll talk about that sometime. Anyway, let's say for a fast food restaurant, they make a $10,000 investment to offer a new food item that sells for $3.99. Now, it does cost them to make each of these food items $1.90 to make it, right? And so what they're trying to figure out is really, should they make this investment? How many would they have to sell of these food items to break even? Because if you're not going to break even, at least, then there's no point in selling this food item and making this $10,000 cost or investment. Okay. And not only that, you really want to make a profit. Now, just so you know, break even is where your revenue, that's the money you take in, equals your cost, right? You're going to break even then, right? Your profit is going to be 0. And that's what your profit is. When you take your revenue and subtract your cost, any money that's left over, that will be your profit. So let's see if we can answer question A. How many food items do you need to sell to break even? Okay, let's make our cost equation first. Notice that we have two costs. We have a variable cost, right? We have an item that costs $1.90 for every item. We'll call that X. So notice if we made 100 of these items, 100 times $1.90, then would tell us our cost to make those items. But plus, we invested $10,000, right? And our revenue is the money we take in. And we're taking in, it's variable, $3.99 per item, right? So we want to know where we're going to break even, where our revenue equals our cost. So that would be where $3.99 X equals $1.90X plus 10,000. So let's get our like terms together. And plus this makes sense. Let's subtract $1.90X from both sides. Then what does that give us, right? We have a 9, a 0. That means that you have a profit per item of $2.09 that you're bringing in per item. But notice that you have to use that money to pay off the $10,000, right, that you owe. So let's take a look. How many, let's divide by 2.09. How many of these items, food items, do we need to be able to sell? Where's my, I had my calculator. Here it is. Okay, here we go. All right, now this really makes sense, right? Because this is what you make per item and you need to use it to pay off the 10,000. 10,000 divided by 2.09. you have to sell 4,784.6. So that would be 85 food items. So you would do some research and see if you can actually, if you believe that you can sell that many food items. If not, then you wouldn't do this. Okay. Now, but let's take a look at B. On top of that, though, you don't just want to break even. Why would you do all this just to make zero money? You want a $12,000 profit right from this. So this is the items to break even. Okay, plus we want to make a $12,000 profit, which means I am making $2.09 per item, and I want to make a $12,000 profit. So I'm going to kind of erase here. Not really worried about cost right now. I'm just trying to make a profit. So I make $2.09 per item, and I want, right, that to equal the $12,000 profit, right? This is my profit per item. Right? So this is my profit per item. So we're making a profit per item of $2.09, and we want that profit to total $12,000. So let's divide by 2.09 and see how many items in addition to breaking even that we have to sell. So that's 12,000 divided by 2.09. So we have to sell an additional 5,742 items to get that profit. So 5,742, let's add that to our 4,785. We have to be able to sell 10,527 items to make our $10,000. Sorry, at the very end, I'm worried. I want to do a good job, and at the very end, so we have to sell 10,527 items to make a profit of $12,000. There, I finally said it right. And I hate to tell you, it's 10 to 10 at night. I'm just trying to get the video done, you know, so sorry for the little mistakes. And so the business decision would be, do you feel that you can sell that many items and to get that profit? And if not, and that profit is important to you to have, then you wouldn't take on this investment. So have a good day.